Hello guys, this is Abhijit and today we will continue our lecture series on minimum mathematics you must know before starting undergraduate physics. This is lecture 2 part 1. We have completed a series of lectures on lecture 1 part A, B and C. In lecture 2 we will study about different types of differential equation and also we'll read about the partial differential equations. Okay, so the minimum prerequisite is you must be good at your differentiation that we have done in lecture 1. Okay, and you must be good at your coordinate systems, it has been mentioned here, and you must be good at also the minimum mathematics lecture 1. Okay, so these are the prerequisite and let us start our discussion today. So today we'll try to understand the physical meaning of differential equations. Okay, what do you mean by differential equations? Let us focus on this equation for a moment that says that dy by dx is equals to 1. So what is the physical meaning of this equation? This equation is saying that there is some function y of x whose slope is 1. So the differential equation is saying that there is a function y of x. So there is some function y of x whose slope, so when we calculate slope, all we do is take d by dx. Okay, whose slope, the value of the slope is 1. So can you guess the value of y such that the slope is 1? I mean, can you find y in terms of x such that dy by dx is 1? The obvious answer is y equals to x. Okay, it's a very obvious answer because it will become dx by dx, which is equals to 1. So this is a differential equation who is trying to convey to us that there is some function y of x whose slope is 1. This is the differential equation, what the differential equation is trying to say. Now then after knowing what the differential equation is trying to say to us, we get the value that the value of y is x. Okay, the value of y is x. So this is a differential equation, this is a differential equation, and this is the solution of differential equation. Okay, now similarly we can get to the solution through another method, that is by using integration. Okay, so when we solve this differential equation by the use of integration, okay, let us try to understand. So dy by dx is 1, so y becomes integration of 1 dx. Since y is constant, since 1 is constant, sorry, this 1 is constant, 1 will come outside, so integration of dx will fetch you x plus c. Okay, c is called as the integration constant. Now the question, the thing is, we got y is equals to x plus c. Now let us see if y is equals to x plus c satisfies this equation. Okay, yeah, let me write it here. So y is equals to x plus c. Okay, so put this value here, put the function here, and let us see if we differentiate, we get 1. Yes, because d by dx of any constant is 0. So what we understand is this is also a solution of this differential equation. Okay, so here comes a very interesting part. The interesting part is that okay, so let us see in this manner. Okay, so the interesting part is this differential equation does not have a single solution, it has a range of solutions. Like c can be anything, c can be starting from 0, 1, 2, 3, 4. So there is a family of functions that satisfies this particular differential equation, not just one but a family of functions. So we know the graph, we know how to draw y equals to x. Okay, we know how to draw y equals to x. All you need to do is take a y coordinate and make a x coordinate, and we learn that y equals to x will be a function in this manner, will be a function like this. Okay, this was our y equals to x. Now We learned this in our previous lectures. What is the meaning of y is equals to x plus c? Okay, so what happens if I add, say, a number 1 here? Okay, so the moment I add a number 1 here, all the values, so all the points x, say all the points here, so this is a point, this is a point, this is also a point, each point gets shifted by 1. Okay, because and shifted by 1 in which direction? In the x-axis. Okay, this is the x-axis and this is the y-axis. So each point they get shifted by 1 in the x-axis, because the x because with x we have added a value 1. So when I say that each point gets shifted by 1, it means I'm saying that there is this line. Okay, there is this line has shifted by 1. So the meaning of y is equals to x plus 1 is the line y is equals to x has got shifted towards the x-axis by 1. Okay, has got shifted towards the x-axis by 1. So we understood that a differential equation, this type of differential equation may not have a single solution. It can have a family of solution, and the explanation is that all the lines parallel to y equals to x, each and every line, there are infinite amount of lines parallel to y equals to x. These infinite amount of lines which are parallel to y is equals to x, all are the solution of the differential equation. Okay, this is a simple differential equation to start with. Let us move on to a bit complicated differential equation. Say another differential equation who is saying that dy by dx is x. Okay, so dy by dx dy by dx plus x is 3. Okay, dy by dx plus x is 3. So let us try to understand this differential equation here. Okay, so what is the meaning of this differential equation? So I can write this differential equation in another form. I can write it as, say I write dy, okay, by dx. So I can write it dy by dx, and I take the x on the right hand side. So what I get this is 3 minus x. Now this becomes quite interesting. So the value dy by dx says that y is a function. Now y is a function of what? We all know that y is a function of x. Okay, so the function y is equals to x has a slope. So when we do dy by dx, it is nothing but slope. Okay, the function y is equals to x has a slope which is changing with x. Quite interesting. The slope, the value of slope is changing with x. So obviously the graph of a function whose slope is changing along x-axis is not going to be as easy as this. Okay, here the slope isn't changing, the slope is same as you move towards x-axis, slope is same. But here this is a type of graph where as you move towards the x-axis, the slope is not going to be same. Yeah, let me give you another example. Remember the function dy by dx is equals to x square. Do you remember the function? And we have discussed in our lecture 1 in detail how dy by dx is equals to x square. Slope changes along with x. So we know the graph of this type of function. It was like this. So as we move towards the x-axis, the value of the slope was changing. It is not straight. So can we try to plot this equation? Yes, this equation has been plotted using a software, and the equation looks like this. Well, it increases first and then goes on decreasing and goes to the negative values. Why does it go to the negative value? It means the slope is negative. Yes, it will, because when you write slope as 3 minus x, when x is greater than 3, so 4, 5, 6, the slope is going to be negative. So for all x greater than 3, the entire slope is negative, so the curve will go down. Now that you can see the graph here, you can see it from here, that after x equals to 3, where it reaches the maximum point, the entire slope goes down. Okay, the entire slope goes down. Now what? Okay, So if we go down, okay, let us try to understand this graph. Okay, so what is the value of function at x equals to 2? So what is the value of the function at x equals to 2? Can we write it? Okay, when you solve this differential equation by using the same integration method, you get the value of y in terms of x. So you can plot the values of x here and you will get the values of y. So solving this differential equation actually gives us a function in terms of x, and at each value of x we can plot the y and we can plot the entire graph. This helps us in plotting the entire graph. Okay, so similarly if I ask you, so question number 1 is, what is the value of the function at x equals to 2? It's very simple. All you have to do is put x equals to 2 here and you get the value of the function is 4. Yeah, that you can see is that at 2 the value of the function, I mean y, is 4. Okay, so it is 4. Now second question is the value of the slope of the function at x equals to 2. Okay, so now you have to put this value x equals to 2 in the slope equation. That is, you have to put the value here. Okay, so this is the slope. Okay, and x is 2. So what is dy by dx at x equals to 2? Is going to be 1. Yes, it's going to be 1. You can see here that all we have done is put 2 in x. Okay, you get 1. Now the third bit says that sum of slope at x equals to 2 and coordinate at x equals to 2 is 3. Now what is the meaning of this? This is the physical meaning of this. Now this can be interpreted in another way, that we have a function, we already know the function, so we have a function y equals to x, the sum of whose slope evaluated at x and the value of x gives us 3 at every point. It's quite interesting. Okay, we are interpreting this differential equation in another manner. What we have done is, we need a function y of x whose slope evaluated at x and the value of x where the previous slope was evaluated. When we add them, we always get 3. Okay, this is the physical meaning of this differential equation that we have seen here. So the slope of the function at x equals to 2 and coordinate of the function at x equals to 2 is actually 3. Let us see. The slope of the function at x equals to 2 was calculated here in the second bit. We got 1, and the coordinate that we have seen, what the coordinate we have taken? We have taken the coordinate as 2. So when you add them, you get 3. It's quite interesting. So this is the physical meaning of this differential equation. Okay, in summary, let me tell you quickly what we have done. We have taken a differential equation, okay, another complicated differential equation, and we used the integration and we found the solution of this differential equation. Okay, then we interpreted the physical meaning of this differential equation. So what is the physical meaning of this differential equation? That we have a function y of x whose slope at x plus the value of x where the slope was calculated always gives us 3, and the solution of this differential equation is this. Now you must be saying that you must be thinking by now, the why is the integration constant? Yes, of course there will be integration constant, and when I put an integration constant here, the entire graph shifts in the x direction by that constant. Okay, so this is not a single solution of the differential equation, but there are infinite amount of graph that solves this differential equation, and those infinite amount of graph are parallel to this graph. Okay, so here I have not given integration constant, but you can think here there has to be an integration constant, so you can put here integration constant and guess it your way. So this is the differential equation, and these are all first order differential equation. You see, these are all first order differential equation where there is no square term, there is no d square y by dx square or something like that. These are all first order differential equation, and we have seen the physical meaning of first order differential equation. Okay, now you might have seen second order differential equation. There are a lot of second order differential equation. One equation is d square y by dx square is 1. So I have given you a very simple equation, and it is your task to find out the physical meaning of this. Okay, I am giving you it as a homework. and in the next lecture series I'll give you the physical meaning of second order differential equation, but please take it as a homework. Where do we use second order differential equation in physics? The most simplest equation is force is equal to mass into acceleration, and acceleration is double differentiation of x with respect to t. X is any coordinate or position of the particle. So we have a lot of equations in physics in second order differential equation. For example, you take a wave equation, it is also a second order differential equation, but partial, it's not complete differentiation. See, these are complete differentiation equation. Okay, d means complete, and when you go to partial, these are partial d's, and the differential equation in these partial d's are called as partial differential equation. Okay, so continuing our discussion, let us try to understand what you mean by partial differential equation. Well, the partial differential equation is written in this form. Okay, partial differential equation with respect to x. So what do you mean by this? When you take a function xy, when you take something xy and you apply the partial differential equation, partial differential, what happens is the y is treated as constant and x is treated as variable, and the operator, let me call this an operator. Okay, and this partial operator just acts on x. So what you get, this becomes 1 and you get an answer y. Yeah, correct, you get an answer y. Now let me give you a small puzzle. Okay, a small puzzle. Till now we were learning that y is a function of x. Okay, so till now we have been studying that our y is a function of x. Okay, now if y is a function of x, then how dare we to take y as a constant and make it go out of this partial equation? Yeah, how did we dare? We should not dare to do this, because y is a function of x. If y is a function of x, we shouldn't have dared to do this. But there is a catch here. When you read about partial differential equation, there is a catch here. Okay, the catch is, although in the upcoming lectures the note says that in the upcoming lectures they are going to discuss the catch, but in this lecture series let me explain you the catch. Okay, I'm not gonna make you wait. So here actually x and y are two independent variables. Here y is not a function of x. Y is itself an independent variable and x is itself an independent variable. Now you would ask me, what do you mean by independent variable? Okay, in what terms are they independent? Well, to understand this we have to go to functions. Okay, let me give you a brief review about functions. So remember, we dealt with functions like y of x. Okay, so y is a function of x, and we wrote something in terms of x in the right hand side. Okay, and the graph of this type of functions, it's like easy. Here you have y and here you have x. Okay, now when you are asked to plot graph of this type of function, what you actually do is, for each value of x, okay, you find the value of y, and then say for a function you get first y here, and then for each value of x you get a y, and you plot a point, and then go on finding the values of y for different x, and then you get various points. Okay, and at the end you join these points and you get an equation. Okay, so whenever you have y is equals to x, and here we have expressions in terms of x, so here whenever we are calculating y, please see that we are calculating height, isn't it? So whenever we are plotting this point, we are actually calculating height. So y is actually the height in the vertical direction in which we are plotting the points. So y are the height. Okay, agreed? Now when I say that there is another case, okay, let me draw a line here so that I can make you understand that in another case the x and the y, they are independent variables. So when I say independent variables, I can make a function f which is both a function of x and a function of y. Agreed? Yeah, agreed. So what is f of xy? So it says that, say we have a x-axis and I have a y-axis. Okay, I'm drawing in this manner, and let me plot this as x, okay, and this as y. Okay, great. Now what is the meaning of f of xy? We know that when we put value of x here, the y was actually a height. Okay, similarly for each value of x and for each value of y, I mean when I say there is a unique value of x and a unique value of y, it means I'm drawing a point on the xy 2D plane, 2D xy plane. So for each point, and this point is represented by, you know, x and y. Okay. So when you plot, so f of xy will be a complicated function in terms of x and y. Here you have terms in terms of x and y. So when you plot x and y and you get f, this f must be intuitively height. Agreed? This f must be intuitively height. So for each x and y in this 2D plane, for every point, for each and every point in this infinite amount of size plane, you plot and you get, for each point you get a height, for each point you get a height. Okay, I'm not drawing it straight, but I hope you get the point. For each point we get a height. So for each point, when we get a height and we join all these points, please understand that we'll get a plane. It's quite interesting. We get what? We won't get any straight line or straight curve, but we get a 2D surface that is plane. So f is a function of x and y. So plotting each value of x and y in f actually gives us a plane. The plane can be anything. Here I have drawn a parallelogram type of plane. It can be any arbitrary plane like this. Okay, and so what should I do? I should do one I should draw one more axis. Actually I should not left out. Yes, so this axis will be called as my z axis. Okay, so when I call this as a z axis, I mean this is actually f of xy stuff. So each f of xy gives you a value of z. So this function can also be written as z as a function of x and y, has terms here in the right hand side in terms of x and y. And when we join all these z points, so these all z points are height, when we join all these z points we get a plane, So I hope you understand. When I said x and y are independent variable, so when I say x and y are independent variable, I mean x and y are taken separately and they are plotted in a function that results in a plane. Okay, so when we think of when we are actually doing partial differential equations like this, please remember x and y are independent points. So whenever x and y are independent points, so concentrate on xy. So do you believe xy is a surface? Yes, of course. When I have written xy here, what does it mean? It means it is a function where, so when I wrote this particular equation here, okay, when I wrote this particular equation here, okay, and when I wrote this particular equation here, so this xy, of course this xy, they are nothing but like any function f of xy, any function f of x comma y is xy. Now can you guess what type of 2D surface is gonna result when we plot this? Well, you can plot it yourself. All you have to do is take a 2D plane for each point x and y, multiply the coordinate, and the number you plot it as height, and then you join all the points and see what type of plane you get. Okay, so this is also a task. So you can do it by your hand, or we have softwares nowadays to plot graph like this. You can use Origin, MATLAB, Mathematica. There are various softwares that you can do. Okay, so I hope you understand partial differential equation here. So the question here, they have ended this section by presenting you that what is the difference between d by dx of xy and del by del x of xy, that is partial differentiation. So when you are considering full differentiation, y may not be an independent point, it may be a function of x, but when you are considering this, it means y has to be treated as constant. This indicates that y cannot be a function of x. So this term indicates y cannot be a function of x. Okay. These are independent variable. Okay, this is the answer. So now you can easily do various problems regarding partial differential equation. You can get in your +2 mathematics books, and we end this section here. So in the upcoming lectures, in lecture 2 part B, we will be discussing in more details about partial differential equation. We will be discussing about wave equations. Okay, and we will also discuss various types of first order differential equation, various types of second order differential equation, and how to solve them. So we have a bit of complicated stuff coming in lecture 2. These are the basics that I have given in lecture 2 part A. So stay tuned for part B. We meet again next week with another lecture series, another lecture video. Okay, thank you.